All right, this is day 2 for climate change, or lesson 10.6. Lesson 10.5, we did an interval. Essentially, we're going to go through again, looking at climate change and do a test this time. And rather than collecting all the data, we're going to just go with the sample that they're describing here. This time we have 32 weather stations that were randomly picked from across the globe. They looked at the temperature early in the 1900s and then late in the 1900s, just like we did in class. And they calculated the differences at each station. And here's what they found. This was their average difference, the X-bar difference, and the standard deviation. So let's dive in. Is there evidence that the peak global temperatures are increasing based on this sample? So the parameter is, again, just like yesterday, mu difference. It is the true mean difference. Make sure you include that word. It's the differences of the temperatures. And we did late minus early. The null is that the average difference will be 0, that the temperature is not going up or down. We would get nothing, no difference. The alternative is it is above 0, namely because the evidence here is that the average we got, doing this 32 times, subtracting them all, so we would have a big list. We would have early and late 1900s. We'd have a temperature of 30.2 and then 30.6 for the difference of 0.4, and then that's one station. Another station could be in a warmer climate. Actually, if this is Celsius, that's pretty warm. Let's say it's a colder climate, like 2.3 degrees, and it only went up to 2.4, so that difference is 0.1. So again, we're getting the average of this list, and they found this and this. We call this a paired t-test for mu difference. Okay, it's paired because each weather station gave you the before and the after. Each individual in the sample provides 2 data points, and then we compare them. It was random. It said as much. The CLT, it said we had 32 data points, which is great. So therefore, it is normal. Booyah. Sweet. Independence. Take your sample times 10 and compare that to the population of all the weather stations. And if you remember that yesterday, here's kind of a picture of it up here. See all those red dots on there? There are way more than, don't know why that happened. Hold on. Crashed. There are way more than 300. Ooh, weird. Like reset. There's way more than, sorry, I got thrown off there. Way more than 320 population of weather stations on Earth. All right. So we're good. Conditions are all met. We're going to use the applet here. You can also do the calculator, but I'm going to do the applet. Okay. So we've got the curve drawn like this. The null is that there's no difference, but our sample gave us a difference of 0.35. When you open the applet up, you can choose one quantitative variable single group, right, like this. And now here we've got temperature. Now we're not going to enter the raw data because we don't have it. We're going to choose mean and standard deviation and then enter what they gave us. 0.35, the standard deviation that they gave and provided was right there. It was 0.296. and the sample size was 32. So the applet can do this, hit begin analysis, choose the right test. This is a one sample t, it's not an interval, this is a test. One sample t test. It's not two sample because they're paired up. And then it says the alternative hypothesis is a greater than, okay? And the hypothesis mean, in other words, what is the hypothesis? What is the null? Is that there's a mean of 0, that there is no change in temperature. And then you perform it. It gives you your t-value, pretty big. That's 6.6 standard deviations, and the p-value is very low, and the degrees of freedom is 31. So let me transfer this over. Okay. Test statistic, 6.689. P-value is less than 0.001. You could also do this on the TI-84 and you'll get the similar values. So, because my p-value is less than alpha, it's practically 0, we are going to reject the null. What does that mean? That means that's when we use the phrase, there's convincing evidence. Oh yeah. Of what? Convincing evidence of the alternative. So put that into a sentence, that the average global temperatures are increasing on average during the 1900s. I just left this blank for that, just to provide as much context as you can during the 1900s. So that's a test, folks. Okay, moving on. Oh, yeah. Moving on, you can see the quick notes. There's a note here about when is it a paired test, which I thought was interesting and worth your time. This is a sample where each individual has two data values. In this case, the individuals were the weather stations. Okay, it's a two sample if the samples are completely separate, or there's two separate groups, like one group got a placebo and the other group got a drug. Those are two samples. Okay. The lesson app is about ice cream. Uh, it's kind of a fun story. It's wondering if generic ice cream, vanilla ice cream, melts faster than the premium ice cream. What they did is at 25 times during the day and night, the girls put a single scoop of ice cream of each type outside and waited for them to melt completely. This again is a paired t-test. Why is that? Because the data comes from two values for each individual. You're like, what the heck is an individual? We're talking about ice cream. Right now, the individuals are the times. So each time of day contributes 2 data points. That one's a little more subtle, okay? And so I guess some of them could be during the night, some could be during the day. Sometimes it could be sunny, sometimes it could be cloudy, but each time of day contributes 2 data points. So again, it's paired. They are providing the dot plot. They're giving you the average difference, the mean difference between the two. They are subtracting premium minus generic, okay? The standard deviation is that. Explain why there is some evidence that premium brand ice cream takes longer to melt, okay? So premium brand, think mu premium, it takes longer than mu generic, right? That's what that means. Premium takes longer. So if you did premium minus generic, you would get a number above 0. So what is the evidence that um, supports that? Supports this? Well, if you count up your dots, there's 25 dots total, and there's only this many dots that are below. underneath it. 1, 2, 3, 4, 5, 6, 7. But all of these dots are above it. And I believe that's 15, right? This is 7 data points. This is 15 data points. And of course, we have 3 data points that are right on. So that's it right there. And that's essentially what this is saying. It says 15 of the 25 data points are positive and only 7 are negative. And the average was positive that we got, the average difference. And then we're going to do the whole test, okay? Statement, we want to carry out a sample to determine if they melt at different rates. The parameter we've kind of addressed, but here it is again. It is mu difference, just like up with the climate change. This is the true mean difference in the melting time for a single scoop of ice cream, again, premium minus generic. Make sure you have the order correct. The null, we've kind of already talked about, is that there is no difference. It would be 0. And the alternative, which we kind of just talked about up here, is that if premium takes longer to melt, it is a bigger number than the generic number. The time is greater. So if you subtract them, you're going to get a positive. So that's why we have that. Our statistic is what they gave us. That's the default. I think they gave that to us as well. And the evidence again is boom, there you go. It's a paired test again, which again was a little bit obscure, but each time of day contributes 2 data points. It's a t-test for the average difference. Random was given, bam, 25 is not 30, but we're okay because the dot plot does not show strong skew or outliers. They gave me the dot plot. That looks pretty nice to me. If I remove those marks, it doesn't really look strongly skewed because maybe you're like, yeah, most of the data's on the right and then it's kind of skewed off to the left. I wouldn't call that strongly skewed. You could maybe argue that, I suppose. And are there like really, really obvious outliers? Maybe you could say that one's close, but it's nothing that's like really obvious. And you don't have the data to graph anyway. So this is all you have to go off of. So I said it doesn't really show any of that, so we can reasonably assume normality. Independence, 25 times of the day, it gives you 250 when you multiply by 10. Is that less than all the times of day that they could have chosen? I guess you could, sure, there's lots of tiny increments of day when you could do this. Kind of a weird idea, weird thought. This independence thing oftentimes gets clunky. Or I just kind of stated it this way. The rate at which the ice cream melts is not affected by how fast it melted at other times of the day, right? How it melts at midnight is not going to affect how it melts at 2 p.m. Do the procedure. Again, the null is 0. The statistic was 1.32, which goes into the formula here. How far is it from 0? And then divide by the standard deviation. If you're wondering where the heck did 1.14 come from, 1.14 was way up here, right there. So way up there. And don't forget to divide by the sample size. Show the work, but then you could also just let your calculator do it for you. I'll do this one on the TI-84. So this is a t-test, okay? And I need to enter the null of 0, x bar of 1.32 and 1.14 and 25 data points. And I get a test statistic of another really big test statistic. So we're getting very convincing evidence on both of these today. And remember, the p-value here is scientific notation, folks. So it's actually 1, 2, 3, 4, 5, 6 zeros like that. Not zeros, like the decimal was right here. And I moved it 6 places over. There we go. Okay, my p-value is tiny, so what does that mean? We're gonna reject the null, folks. Okay, it's pretty much 0, which is less than 0.05. What does that mean? Whenever you reject the null, you use the phrase, there is convincing evidence of the alternative hypothesis that the average difference in temperature between the ice creams, oh my gosh, it's late. The average difference in time it takes to melt between the two ice creams is above 0. It takes longer for the premium ice cream to melt than the generic ice cream is another way to say that. Sorry, it's late. I kind of stumbled over that last part. See you later.